Okay, so we'll move on, and we gotta cover chapter 9 here, okay? Okay, maybe we won't get through all of it, and then next week, then I'll just make sure the quiz covers just the parts that we did get through, of course, okay? Yeah, maybe, I don't know, I'll figure something out if I don't get through it. Okay, basic question. Very important. This stuff with proportions, okay? Hypothesis test for proportions. Do we use it for categorical data or numeric data? Fail, no.
Yeah, you could measure it.
Categorical data. There's no.
Yes.
Do you watch Big Bang Theory? Yes or no? That's categorical.
Yeah.
Are you a man or a woman? Categorical. There's no quantitative data here. Okay. Sure, we've got numbers, but that doesn't mean it's quantitative data here. Okay. This is categorical data. If you don't know that proportions are for categorical data, yeah, I mean, you better learn within the next couple of weeks, okay? Because you will be in big trouble. No, not hypothesis testing. Proportions. Proportion tests, confidence intervals for proportions, all of this proportion stuff is for categorical data only. Do you watch Big Bang Theory? Yes or no? That's categorical. Are you a man or a woman? That's also categorical. You cannot tell me that's numeric data. Unless, I don't know. How many times did you turn on the, I don't know, it doesn't work, okay? Alright, so, on the other hand, so categorical data, that's one type of data we've got. Now we've got numeric data. Can we do hypothesis tests for numeric data? Yes, and we're going to learn how, okay? So, hypothesis tests and confidence intervals. This is chapter 9, right? This is chapter 9. We got a lot to cover. So the question here is, well, we're going to be comparing means, or we're going to be making confidence intervals for means and things like this, okay? This is all based on, do you guys remember what happened with the central limit theorem? Okay, no, you got to check conditions to use the central limit theorem, but what was the whole idea behind the central limit theorem? Normal. Yes. That's it, okay? What about the normal?
Normal distribution.
Of course it's a normal distribution. What is a normal distribution? According to the central limit theorem, what ends up being a normal distribution?
Isn't it like the mean they're both the same on both sides?
Okay, no, it's the sampling distribution. That was what I was looking for. I wanted somebody to say sampling distribution follows the normal distribution. What's a sampling distribution? Crushed my heart. Okay. Okay. Sampling distribution is if we take different samples from the population and we studied a certain property of the sample. Okay. So last chapter, the property we studied was the proportion, the sample proportion. When we look at all the different sample proportions, the distribution of those p-hats follows the normal distribution. That was the central limit there. Okay, we're going to do the same thing, but for a numeric variable. We've got a population. If we take samples from the population and we study one characteristic of that sample, this time the sample mean. And we study all the different possible sample means that can be generated. The distribution of those sample means follows the normal distribution. Okay, that's the central limit theorem for, I guess, quantitative or numeric variables. Okay, so let me just put that up here. And the idea is we have a population. Okay, we take a sample of size n. And we calculate the sample mean x bar. Someone's having too much fun for statistics here. Okay.
Of size n?
Of size n, yeah, right? Because we always have a sample size. And so we calculate the sample mean x bar. And if we did this many, many, many times, and kept track of all the x bars and made a histogram, we would have the normal distribution. And so then we say x bar comes from the normal distribution, and the mean is mu, and the standard deviation is sigma over the square root of n.
That's the formula for...
Oh, this is just the normal distribution.
Oh,
Do
Okay.
we need to know this formula?
I mean, put it in your notes, but I won't have any test questions off of this, okay? I know, that's all you guys care about. Is this gonna be a test?
Go ahead.
So when we did a confidence interval, what did we do? For proportions. We took a sample. This is a sample here, okay? And then we calculated the proportion from our sample. So let's say, you know, I surveyed 600 random men. I said, do you watch The Big Bang Theory? 120 said yes. So my sample proportion is 20%. So then I said, based on my sample proportion of 20%, I can then say I'm 95% confident that the what? That the not the
interval,
that the
proportion falls between this
proportion
one,
of men
watch
in the
Big Bang
population
Theory.
who watch Big Bang Theory is between
this number and this.
some
Whatever
this number
we
and
get
that
from
number,
margin of
where
error.
basically 20%'s right at the middle, and we go plus or minus
Yeah.
some percentage, right? Now, what was the concept? Why was I able to go 20% plus or minus some number?
The margin of error.
What about the normal distribution? The idea was, so we know that the p hats came from a normal distribution, meaning the p hat would be, according to the normal distribution, would be close to the population proportion p most of the time. Same concept applies here. Now we're going to observe a sample mean, an x bar, and we're counting on the fact that x bar is not very far from the population mean. Okay? There is a catch though, in that here our normal distribution requires that we know sigma. What is sigma? Or what is this number over here?
It's the standard deviation.
Standard deviation, yes. Okay? So this requires that we know the mean of the population and the standard deviation of the population. Okay? But remember, the idea here is that we don't know the mean of the population, that's why we're making a confidence interval. And if we don't know the mean of the population, do you think we'll know the mean of the standard deviation of the population? No, we're not going to know this either. So, what am I supposed to do? Can I guess what the standard deviation of the population is? Well, how should I guess what the standard deviation of the population?
Do the formula when you have
No, because that's only for categorical variables. Okay.
Wait, it is possible?
It is possible.
Oh,
it is
okay.
possible.
I didn't realize
Yeah.
that I was.
Would you take an average of the number?
Well, the average of the numbers would give me a sample mean.
Yeah.
Okay.
Isn't it close to it?
Yeah. Okay. All right. So let's just say okay. So let's talk about confidence intervals. Confidence interval for population mean mu. Okay, the population mean. All right. So let's say you've got a little brother and he has this odd fascination with I don't know.
Not Power Rangers.
Maybe not Power Rangers. Huh? Move this down? Okay, there's nothing exciting there. Alright, let's say he's got this odd fascination with oranges and how big an orange is, alright? And so he's like, oh man, and he somehow he goes around and he gathers a whole bunch of different oranges and he's like, I want to know what the true weight or the average weight of all oranges in the world are. Okay, and this is ridiculous, but he's like, I want to know what the true average weight of an orange is. What is the true? I have no idea how much an orange weighs. Okay, so let's say he goes around and he gathers a bunch of oranges. Okay, and so he picks out some random oranges and he weighs how much they are. Okay, and so let's say the first orange he weighs is 290 grams, and then he weighs another orange and it's 240 grams, and another one is 280, and another is 260, because his scale doesn't do anything other than tens places, and let's say 270. Okay, so here's we have 5 oranges, and this is all he could afford. All right, based on this, I'm going to create an interval of what I think the true average weight of an orange is. Okay, so what is my x bar here? So from his sample, $268. This is. So I'm making up numbers. I have no idea if this is that close to an average orange or not. Okay. So based on these 5 oranges he selected, the average weight is 268 grams. Okay. So, but he's not going to say that the true average weight of all oranges ever is 268 grams, is he? No. And he has no idea, so he has no idea what the population mean is. Okay, we want to make a confidence interval for the population mean. We have no idea what it is. And we also have no idea what the population standard deviation is. We have no idea how much difference there is from orange to orange in the general population either. Okay. can we get a rough idea of what that standard deviation might be? How? You don't know? Okay. Well,
You said we could. So we
I
don't.
said you could, yeah. What do you think a reasonable way to estimate the population standard deviation would be?
Just keep the middle one out of the order.
The middle one?
Yeah.
Wait, what was the question? I'm sorry.
Okay, I have no idea what the standard deviation of the population is. Right? I have no idea what that is. How can I get a reasonable estimate of the population standard deviation?
Well, you take the average and subtract it from like the highest number you picked and the lowest number you picked.
Yeah.
The range.
Okay, so these are
Well-
ideas. I would say the best idea, though, nobody mentioned, is why don't I just take the standard deviation of the sample and use that as an estimate of the population standard
Isn't that what
deviation?
I just said?
Well, you said take from the largest and the smallest, but I just want to figure out the standard deviation of the sample. Do we know how to get the standard deviation of a sample?
Yes.
Okay. Can you guys do this? Take the standard deviation of these 5 numbers. All right, race me. If you beat me, I'll give you 5 bonus
Sure.
points on your next quiz. Okay.
2 seconds later.
I know. You can't. No winning against me. No,
This is not fair.
What do you?
what am I doing? I'm cheating right here. I'm gonna beat you right now.
Give us a head start.
Okay, I will count to 10, and if you can give me the answer, because I've got the answer right now.
What are those? Now,
These are shortcuts to get the.
why aren't you teaching us the
No,
shortcuts?
it's not. They're not shortcuts. I'm just writing down numbers to keep track.
Sure.
Okay, so I'll say 10.
That's a 20 seconds
That was a very quick second.
Okay. I'll start my 10 seconds over again. Nobody? Wait. All right. No, nobody got it. Okay. 19.23. Oh, you just got it.
No, I didn't, but I was like almost.
Okay, can you tell me what you
Okay.
got it?
So what these are? So I just did 290 minus 268 is 22. 240 minus 268 is 28. 280 minus 268. And 260 minus 268, and 270 minus 268. That's what all of these numbers are. And then I squared them in my calculator. And then I added them, and I divided by 4, and I took the square root.
This is for the standard deviation?
For the standard deviation,
Wait, why do you
So-
divide by 4?
divide by n minus 1.
Okay, you're right.
Okay, well anyway, so that's my standard deviation. So this can serve as a ballpark number for the population standard deviation. Okay, so the standard deviation of my sample was 19 grams, 19.23 grams. Huh? Yeah, as always.
You said square them and divide by 5,
Can we get one more
right?
challenge?
Square them, add them up, divide by 4,
But why 4?
n minus 1.
Because
Which
the
I might
Oh,
come
yeah,
up with
that's
for
right.
standard
Can
deviation.
we
Yeah,
get one
just-
more challenge like that? I can use the 5 I can put it.
I know, everybody can. Okay, so what we've got here is 268, 20.23 grams as the standard deviation. This can serve as an estimate for the number of standard, for the standard deviation of the population. Okay. However, is this going to be the standard deviation of the population? No.
No,
Okay.
it's not the same.
There's some uncertainty here. Okay. There's some uncertainty here. Yes.
Isn't there a lot of uncertainty because the sample is only 5?
Yeah, there's a ton of
First-
uncertainty. You're absolutely right.
He
Okay.
was poor, couldn't find more than 5 oranges.
Like,
Okay.
would it even be worth doing that?
Well, it's better than putting in no guess, right? I mean, a crappy guess that's somewhat reasonable is better than just a totally made up guess. Okay.
But you can't, let's say on the 5 final or the quiz, we can just make up our own numbers and do our own.
No, I'm gonna give you these 5 numbers and then you can.
It's just for purposes of learning.
Yeah, okay. So because this is not the true population standard deviation, we've got to compensate, okay? And this is where it gets a little unfortunate in that we're not going to use the normal distribution anymore. We're going to use this compensated normal distribution called the t distribution. So I've got to introduce the t distribution.
So because it's why did you say because we can't use the normal
Okay.
distribution because
If we knew the standard deviation of the population, if we knew sigma,
then
we could use the normal distribution. But we
now
don't.
that we have the sample.
We're guessing what sigma is.
Okay.
And so we've got to compensate for that extra layer of uncertainty. Okay? And so we're going to use the t distribution here. Okay, so if you turn to in your book
We use the t table.
to page A7. A7, you've got the t distribution. And this tells you for a certain level of confidence, so if I want a 95% confidence interval, the number that I'm going to use, my critical value is well, I've got several numbers to choose from here, okay? So we've got to look up something called the degrees of freedom. So the degrees of freedom is equal to my sample size minus 1. So how many degrees of freedom do I have for this problem?
4.
4 degrees of freedom. Okay? Degrees of freedom is equal to sample size minus 1 or n minus 1.
2.766.
So in this case, I have 4 degrees of freedom. So the number I'm going to use for this confidence interval is 2.776. Do you guys remember what is the z star that I use for a 95% confidence interval when we're doing proportions? 1.96. 1.96. Do you guys remember that?
Yeah.
Okay, look at your t table, and if you have infinity degrees of freedom, what is the number that you use for 95%? 1.96. That's not a coincidence, okay? And you'll notice that these all match up the other numbers that you had to write down. 1.28, 1.645, 2.58.
It's always will be and always has been.
Yeah, always has been. Okay, so the reason why the infinity numbers match up with the z-score, why would the infinity numbers match up?
Because it's the actual population of ever will and ever
Yeah,
was.
so if your sample size is infinity, meaning if you've sampled everybody in the population, your standard deviation of the sample is actually the population standard deviation. And then at that point, the t distribution becomes the normal distribution. Okay, that's
Limited.
maybe a little bit more advanced than we need to be. Okay, so to make a confidence interval, it's going to be x bar plus or minus my critical value t star times the standard error. Standard error, okay?
Oh, we're replacing
Yeah.
the z-score, right? The
Yeah,
critical
it's
value.
now the critical value is now 2.776, and my standard error is going to be s divided by the square root of n.
Wait, that is your what?
That's my standard error.
T is this.
That comes from the table. It comes from the t table.
Standard error.
So my x bar is 268 plus or minus, and my t star is going to be 2.776. My standard error is s. What is s?
Yeah.
divided by the square root of n, what is n? 5. I have 5 numbers in my sample. Okay, so then what is my confidence interval? Can you guys punch this into your calculator?
So you would say you're 95% confident that the average weight of an orange is between 244.1 and 291.9.
Exactly.
Interesting. I entered in the same you did, but I got for the second number 291.8.
291.87 probably.
Well, 787 I rounded
77.
up.
Okay, that's close enough.
Yeah, but I just don't know why we entered in the same numbers.
Compensated up to 95, right?
Alright, so I would then write I am 95% confident that the true average weight of an orange is between 241.4.1 and 291.9 grams.
The x bar plus minus t. What's that formula again for the
Confidence
for,
interval.
Yeah.
Okay, and this is for one sample proportion. Yes.
268 plus or minus 23.9 is 244.1.
And 291.9. Because 268 minus 23.9 will give you 244.1. 268 plus 23.9 will give you 291.9. So that is a confidence interval for a single population mean. All right, let's take a break, and then and we'll continue on.